Okay, we're going to look at one more example. And again, it's a piecewise function, g of x. It's given us two equations. The first equation is x cubed plus k. And this is if x is less than or equal to 3. The second equation is k times x minus 5. And this is if x is greater than 3. So it wants us to find the value of the constant k that makes this function continuous. So we want to find a value of x equals k. Sorry, not x equals k. A value of k that makes this g of x continuous. Okay, so k is just a constant. It's just some number. I'm trying to figure out what that is. Only problem that we would have with this function of where it wouldn't be discontinuous or could be discontinuous would be where it's changing equations. And so where it's changing equations would be at x equals 3. So let's first look, and in order for a function to be continuous, it has to have a limit. The limit has to exist. So we know for a limit to exist, the left-hand side and the right-hand side have to be the same. So let's first look at the limit as x is approaching 3 on the left of our function g of x. Okay, so again, this would be approaching 3 on the left. These are x values which are smaller than 3. X values that are smaller than 3, we'd use this first equation. Okay, so don't get caught up because there's multiple variables in here. So this would be saying we're going to look at the limit as x is approaching 3 on the left of x cubed plus k. We're just going to go in here and we're going to do direct substitution. So wherever we see that x, we are going to replace it with our 3. So doing that, we have 3 tells me to cube that x. So 3 cubed plus k. So 3 cubed, 3 times 3 is 9, times 3 is 27. So this is 27 plus k. So right now, that is my left-hand side limit. My right-hand side limit, the limit as x is approaching 3 on the right-hand side of g of x, well, these are values where x are bigger than 4. I'm sorry, 3. So that tells me I'm going to use my second equation. So looking at the limit as x is approaching 3 on the right, says to use the second equation, which is k times x minus 5. So let's go in there and again do direct substitution. It's the x value we're approaching. So let's go back in, and wherever we see an x, we're going to plug in 3. So we have, this is equal to k times x, so k times 3 minus 5. So for it to be continuous, again, the limit has to exist. So we know that the limit as x is approaching 3 to the left of g of x has to equal the limit as x approaches 3 on the right of g of x. We just found what that limit as we're coming in on the left was. That was this 27 plus k. This has to be the same thing as it coming in on the right, which we just found to be k times 3 minus 5. If it's okay, I'm going to rewrite that as 3k. Doesn't matter the order of multiplication, minus 5. So the goal is to figure out what k has to be. In order for these two sides to be the same, we need to figure out what k is, and that's what we're trying to figure out for this problem. So let's find k. It's a linear equation, so we want all the variables, terms with the variables on one side, all the constants to the other side. So maybe let's add 5 to both sides of our equation. Let's get that k on the left-hand side to the right, maybe, and so let's subtract k on both sides. So if we do that, we have 27 plus 5, which is 32. And this is equal to 3k minus k, which is equal to 2k. K cancels on the left, 5s cancel on the right. We're almost there. This is a k, not an x. And now divide both sides by 2 to get k by itself. We get that k is equal to 32 divided by 2 is 16. And so we figured out what k has to be in order for g of x to be continuous at x equals 3. If we wanted to, we could go back in there and plug in k, 16 for k, to give us that piecewise. But it only just asked us to figure out what k was. So that is in our book 3.2. So we technically covered 3.2 today, and we finished up finally 3.1. And so homework for this week is 3.1 and 3.2 for the My Math Lab homework.